Hi, this is Kevin. Welcome to the tutorial for exercise 2 for chapter 8 of the Zelle 3rd edition book. And again, what we're doing here is we're going through a bunch of these um, demonstration programs that I provided in the weekly schedule. And the one that we're going to do right now is called '08 Recovering from Bad User Input Using While. So this is going to be a slightly more user-friendly version um, of the program that we just did. Okay, and again, I'm not really expecting you to type in everything, but I think it would be good for you to kind of follow along with me and kind of build this piece by piece without having to do the typing. Open it in another editor and then do the kind of cutting and pasting that I'm doing. Okay. So I'm going to create a new Python file. This one is called underscore '08 recovering from bad user input. Bad user input using while. And again, this is too long-winded for a typical Python program name, but it makes a good title for the example. And I'm going to bring over the doc string that I have here. And this is maybe a doc string that's appropriate for one of these example programs, but is maybe a little too long-winded for a program that we'd write on the job. So let's see what it says. It demonstrates recovery from bad user integer input using while. It uses the sentinel loop, well, we used that before, and catches bad input using a try except block. Well, we've seen that code before, but we've never really used it in exactly this concept. And this code is going to implement the usable integer adding machine. Okay, so this is going to be even more usable than the last one. Not only are we going to allow the user to give us a flexible number of integer values, but if they give us an improper value, we're going to reprompt them. Okay, so we're flexible and we're recovering from user input errors, which is why we call this the usable integer adding machine. Okay, so let's do some of this initialization. Okay, and I'm going to bring over um, the declaration for main and the initialization code. Okay, let's go down here and we're going to have the call to main and the empty line after it. Let's put those down here. Okay, so now we've got kind of a proper program. So what are we doing in this initialization block? Well, we're printing welcome to the usable integer adding machine, okay, which again is kind of polite and cool. We are initializing a counter so we can count the number of entries that we get, and we have an accumulator, the sum of the entries. And again, by giving them integer zeros, I'm kind of signaling that we're doing integer math. Okay. And then we have our priming read. So when we're using this, design pattern for flexible user input, and we're using the while. The while always works well if we've done a priming read before we get to the while statement itself. So that's always typically the last thing we do of all of our initialization activities is we do the first read. We call that the priming read. Okay, let's look at the while. Okay, so we're going to bring over the while and all of its code. We'll skip a space for drama, blank line for drama. Okay, so we're doing the same kind of a while. So we're saying while entry as string is not equal to the empty string. So we're prompting the same way. We're saying, please enter an integer value to be added, and then in parentheses, enter to stop, okay? And even if they give us just an enter on the first one, well, then we're not going to perform the body of the loop because we're not going to pass the test at the top of the while. And what we've done is we've taken the code that we have and we put it into a try-catch block, okay? And we're doing a little bit of a programmer trick, right? We're going to put this conversion of the entry as string to entry by calling int. We're going to put it in the try block. But we're also going to put two other things in the try block, which makes this fit into the while loop very well. So if in fact we're able to convert the entry, okay, well then we're going to use it. We're going to up the count and we're going to accumulate. If not, we're going to print an error message, okay, and then we're going to prompt again. So what's really interesting is because the design, which is kind of the same one that we used in the last example, because it already is in a while loop, okay, well then as long as we protect these two pieces of work, increasing the entry count and accumulating the sum, as long as we protect them by the try, well then the user can give us all the bad input that they want to, and we're not going to keep increasing the count, and we're not going to try to accumulate it. Okay? The error that we print is a pretty one using an F string. So we say an integer value was expected, you entered, and then we give them exactly what they entered. And then, of course, we naturally come to the read that's at the bottom of the while loop. And again, the pattern that we're using has the reads. It's got one at the end of initialization. That's the one we call the priming read. And then the one that is in the loop is always at the very bottom of the loop. Okay, so when we enter the top of the loop, the read has already happened. And because we don't have an empty string, we know we have at least what purports to be a proper entry. And we'll find out if it's a proper entry because we're putting the work that we're doing in the try, okay? And if that goes wrong, well, then we're going to print an error. And then very conveniently, the reprompt is down at the bottom of the loop. Okay, so the position of the reprompt is good for the case where the user has given us a proper int, and the position is also favorable for the one where they've given us some sort of a bad value that we're going to have to recover from. It just works out in a very pretty way. Okay, what's left? Well, just like before, we just have a couple of lines to finish up with. Okay, so let's do that. And we need another blank line, I guess. And let's look at what happens with here. So if the entry count is equal to 0, well, then we're going to say no entries were provided. Else, we're going to print pretty output that says the sum of these however many entries is the sum of the entries. And again, because this is an integer adding machine, we can put a period at the end because it's not going to get confused with a decimal point. And even if it is confused with a decimal point, it's going to be interpreted correctly. All right, so that's all the code that we need. It's not real different than what we did before. We just took the working code that we had in the while loop and we surrounded some of it with a try except block. That's all we've really done. And because we were in a while loop, well, it worked out very favorably. So let's do some testing. Okay, so welcome to the usable integer adding machine. Okay, let's just give enter as the first response. No entries were provided. That's good. All right. And then let's give, in the next test, let's give 3 good responses. So we'll give them a 1, we'll give them a 2, we'll give them a 4, and then just an enter. And it says the sum of these 3 entries is 7. That's right, that's what we wanted. Okay. And then let's do some bad input. So right off the blocks, let's give them a hi mom. Hi mom. An integer value is expected. You entered hi mom. Now, I'm pretty sure this is going to work because I know how I wrote the program. But what if you had one bad entry and then what if the user said, well, I want to stop, so they pressed enter. No entries were provided. Well, this is a pretty robust design that we have here. It worked the right way. Okay, and then let's get going along. So let's say we want to add a 1. And then let's say instead of 2, we say 2.2. That's not a proper integer, so it's going to tell us. We can say, oh no, I meant 2. And let's say instead of 3, let's say we said 3 dot. And then it tells us. And then we said, oh no, we meant 3. And let's press enter to stop. And it's going to say the sum of these 3 entries is 6. So not only is it giving us the right accumulated sum, but it's counting only the proper entries and not the error ones. And that's because we protected both the accumulation and the counting with the try. So these things only get executed when we have a proper value. If we don't have a proper value, then we print the error message and we prompt again. It's pretty neat. So the example that you're going to do is slightly different. So good luck with that. And I'm going to say bye until next time. Bye-bye.